Turn on the camera. Perfect. We see you. So, guys, welcome to the fifth lecture of our global lecture series. This time is Beirut turn. It's a pleasure for me to introduce Edouard Cabey. Edouard is a registered architect at the Catalan College of Architects in Spain, and he's graduated from the Architectural Association School of Architecture in London. After gaining professional experience in London, Tokyo, and Brussels, he founded Aparell in Barcelona in 2011, an office developing architectural and research projects both in Spain and abroad. In parallel to practice, he currently teaches at the Institute of Advanced Architecture of Catalonia in Barcelona, as studio director, and as a studio director at the EPFL in Lausanne. He has taught at the Architectural Association School of Architecture as a diploma unit master between 2010 and 2013, as at the IAC as Faculty of Digital Fabrication, and it also has been Associated Professor at the École Spéciale d'Architecture in Paris from 2012 to 2015. He has extensive experience in the format of international short thematized courses and workshops. He is, for instance, the director of the AA Visiting School in Barcelona, ran the workshop Créer and Vivant with Michel Gondry. Sorry for my pronunciation. An encounter between architecture and film at IAC. He is hired by the University of Sinaloa, Mexico, for a yearly workshop on one-to-one construction of innovative structures. He coordinates House One, an EPFL first-year project, of which the outcome is a one-to-one construction in Lausanne and Versailles. Edouard Cabey has lectured and run workshops in Spain, Colombia, Iran, Morocco, Serbia, Italy, France, Belgium, Serbia, again, Mexico, Singapore, India, Ecuador, Switzerland, Georgia, and Ethiopia. So, let's give a warm welcome to Mr. Edouard Cabey, and welcome with us.
Aldo, thank you so much for the introduction. Thank you very much for the invitation. I think it's very suitable somehow, the situation, because I'm now in Versailles, in Paris. I will be in Barcelona tomorrow, but it's interesting to give a lecture in Beirut from France via Barcelona, broadcasted in different places of the world, and that's a little bit the direction in which the world goes. I think it's the direction in which the direction that the IAC is exploring, and it's also a consequence of the society in which we live at the moment. As Aldo mentioned, I'm just to introduce myself with a couple of sentences. I'm an architect in Barcelona, where I have my office, Aparell, which at the moment has a somehow experimental dimension, and then in parallel I'm going to show quite a few projects, and in parallel I have an extensive teaching life in France. I've been teaching recently in Switzerland, in London, and at the moment, well, actually the school where I am most involved and for the future is the IAC, where I've been teaching for 6 years by now. And the presentation is going to be some projects from the office and some projects from the academia, the academic world, and you will see very little difference. I will not always specify academia practice, because I consider that all of them, they form a body of research. Maybe now I will start to share the screen. Great. Which is this here. All right. Aldo, do we see the presentation?
Still no. Don't worry, we can check together. So again, back to screen share.
Sure.
And then you may select the file that you want to share.
Okay, I will share the desktop.
Yeah.
Okay.
Yes, yes. Now we see it. Perfect.
All right.
We need to mute it. But yeah, we're seeing the screen. It's okay.
Now it's
there is going to be sound also on some of the animations, anyways. So the lecture that I'm going to give now it goes together with research that I'm doing at the YAC. I call it Machinic Protocols. Why this title is it's for two reasons. The first one is it's an interest for technology. It's an interest for how technology is shaping our society, is shaping our activities, is shaping us as people, and also as architects, as craftsmen, as constructors. So I think that for us who are architects, the technological advancement that we are witnessing since always, especially since the digital era, is having a very strong influence on the way we design. And the lecture is going to be partially based on giving you my point of view on how new technologies are changing or challenging the way that we design and potentially can augment it. Protocols is it's related to the fact that when we design, we operate with rules. We are never completely free. We always relate to realities. And as a matter of fact, when we design, we use hierarchies. These hierarchies, sometimes they can be related to the environment in which we construct. Sometimes they can refer to the structure, to the materiality in which we operate. They can relate to program. They can relate to technology also. All of them, they are always involved within the design process. So what I've tried now what I've tried to do in the presentation that I'm going to show you is to do. I'm going to show you 14 projects in which this hierarchy is always changing. But it's a little bit of an explanation on how a design process can work, and also how, although within design we always need to use our intuition, it's extremely important. Also, how do we, when we design, how do we relate to a reality? How do we base our design on a set of information that we need to go and collect from somewhere? No, so the translation of information from something that we found into something that we design, sometimes into a form, but into many different outcomes, is something I'm going to focus on. And let me start here with a project that that some students did at the YAC in a studio that I ran last year. So this project is a speculation on. It's a master plan for public space in Barcelona, in an area called Glorias. It's one of the largest public spaces in Barcelona. And we were working with the students on planning a future for this space in the scale of 50 years, not in a fixed time in which a building site would take place and then the square would be arranged or refurbished, but rather to try to understand design over time and to understand it over a very long period of time. So what the students did here is they incorporated a dimension which is to bring to convert the public space into an area where the rubbish of the city, would be treated and would provide different materials. The recycling would provide different materials in order to continue to construct the public space. So they were speculating on 3D printing, reusing all the plastic that is to be found within trash, within rubbish, to be able to be transformed into plastic that then gets printed into urban furniture. So to try to have a feedback loop between the material that arrives on the square and how this material, after being treated, can start to serve to plan the space and to have an effect, therefore, on how people use the public space. I like the fact that in this project, it's very much a project about space in the large scale. It's not a project in which the technology of 3D printing from recycling material is being addressed or is being solved, but rather being used. And technology, I think, is something that that we can all introduce, that we all have to introduce within our work. I was asked a year and a half ago to speculate on the role of architecture within contemporary society. I changed the question because, in my opinion, this question was maybe too difficult to answer, and I challenged the question and I transformed it into what can be the role of technology within our society. Technology is something that is incredibly useful, but that can also be scary at the same time. We have a past. We have a future, and in my opinion, it's about being able to juggle or to use whatever is behind and whatever is forward. But at the moment when I was thinking about the answer to that question, the role of technology, today, Finland had voted a law which is that handwriting since 2016 is no longer a compulsory course within primary schools. So in other words, in Finland, primary schools, it's no longer necessary to learn how to write by hand. That is a question that immediately provoked me. I think it provokes all of us. I think we use our hand extensively. I think we also use the computer more and more. And so what I decided to do is to ask my nephew in Brussels at the time to write the title of the article of The Guardian, which states, Finland is one of the countries to stop making cursive handwriting classes compulsory. So my nephew, Jules, that you can see here on the left of the screen, is writing. He's learned to write 6 months before this experiment. And he's simply writing on a sheet of paper. He's copying the title of The Guardian. And I scanned his handwriting, and at YAC, with the robot adapting a pencil, we have reproduced his handwriting almost in real time. So I liked the fact that the robot, this very complex machine, the KUKA, this arm that operates with 7 rotation axes, that is as large as 6 meters and that can do incredibly complex things. Suddenly, we were asking this robot to reproduce the handwriting of a child, which is probably quite contradicting, because the handwriting of a child, it's deeply insecure. It's he's still learning. It's a handwriting that is not precise, that is very childish, no? That is very young, that is very virgin of experience. While very often the robotic world or the machine we associate as something that is precise, and that doesn't do mistake. So to ask the robot to have almost a kind of a human behavior here was something that I found interesting. For us, I think as architects, there will always be this debate of what needs to be drawn by hand and what needs to be drawn with a computer, or whether is it better to cut with a manual saw or is it better to cut with a digital saw. And I think this is my way to answer that both will be always useful, and that it's all about the skills that one wants to develop and wants to use to be able to achieve his goals. In the continuation of this project, we invited Michel Gondry to the YAC. For those of you who don't know, Michel Gondry is a film director. He's done numerous films for the movie industry. He started doing his videos together with Björk, and he's also produced a lot of long films that has led him even to gain an Oscar. What I liked about Michel is that he works with special effects, but he completely accepts the fact that a constructed reality can be perceived as a constructed reality. Things don't need to be faked. Things don't need to be necessarily polished. We can see them as they are. And the idea of this workshop, which we called Crade Vivant, which means literally dirty and alive, was to try to use the robotic equipment in the YAC to make a film. So we did a process that I think we can consider absurd. What we did is we filmed very short clips within the city of a movement, and then we took these images. We were trying to transform these images into physical constructs. So by using the technology at the YAC and by using different types of material, we were translating an image into a three-dimensional physical piece. Sometimes with clay, sometimes with nails. I will show that to you afterwards. With these physical constructs, once we had done all of them, we re-photographed them in a very precise condition, and then we animated them back. So actually, all we did is a series of translation process from an image to a three-dimensional piece back to an image, from a movie to a movie, going through the physical world. Here is then the movie, the outcome of the workshop. So you see in this in this film a lot of techniques, actually a lot of digital manufacturing going behind it. I think one of the things that we were interested in doing was to use probably the technology for something it hasn't been invented for. No? So in other words, to construct a three-dimensional assembly in order to extract an image out of it. So it's a completely experimental practice, and I think it was a great experience, especially because until the very end of the workshop, we actually didn't really know what this piece that I've just shown you would look like. But okay, I'll switch now to a project from the office, which is a few years back. I've mentioned in the beginning that I'm interested in explaining what are the forces that that drive the design process, and this is an example of how we can use information literally to design. It's a project we did in 2012 with a theme that is incredibly contemporary, which is the production of the city. In this case, the relationship between the city and the production of vegetable, where the city outsources. You know that in the case of in the case of an American lettuce. A lettuce, before it is being eaten in America, it grows in America and then it goes to Mexico to be packed, and then it goes back to America to be eaten. It seems to be completely absurd somehow as a process, but it really happens like that. The question of the fact that production can start to reuse, to come back into the space of the city, is, I think, something that many people are exploring, and this is the basis for this project here. So we initiated the project with a couple of technical hypotheses, understanding or using an incubator, a closed environment, a little pool, in which we control the amount of light that penetrates, the amount of water that we have, the humidity, the amount of oxygen and of CO2, and also by controlling all of these factors, we are able to control actually the growth of a plant inside. A lettuce takes, for example, 42 days in order to grow. So we imagine a helicoidal system where the top of a vertical equipment signifies the beginning of the growth of a plant, and the incubators in which the plant grows slowly travels down in a spiral fashion the vertical structure until it reaches the bottom and is a mature plant that can be consumed, that can be eaten locally, or at least in the area where this equipment is present. So actually, to be able to design the form, to be able to design the density, to be able to design the pathways in which these vegetables need to travel, we had to go and list the parameters that these plants need in order to grow. No? So we were looking at light, we were looking at the quantity of days, we were looking at the quantity of water, all of the somehow numerical information, the quantitative information, to be able to provide, to actually materialize them and to provide the plant with them. So here we did a couple of images just to understand a little bit the type of geometry we were playing with. I think it's definitely a speculative project. What we were looking for here is to understand a relationship between quantitative information and then a resulting structure that was really just created by instrumentalizing these numbers. So here is the process. We worked with a base that was 20 by 20 meters, certain height, and actually we started at the beginning with physical models, hanging threads, understanding that the thread mimics the path of the plant all the way down the structure, and then by actually introducing the numbers, the necessity of the plants, we started to locate incubators and understanding how their process of traveling the tower would be. So this is one of the first projects in which we used Grasshopper, actually. And a lot of the work was being done on creating the definition. In other words, to create this translation process between the requirement of the plant into a form, which is the mere outcome of a series of values. So you can see that we did many iterations. The outcome that we'd get, as I mentioned before, is a form, is a shape. It's actually even a building, although it needs afterwards structural development and so on. But it's also a quantity in terms of plants production. No? So depending on how many incubators we have, the speed at which they go down, we are able to produce different quantity of food for the CD at the bottom of the structure. So here you can see one of the configuration for which we settled. No, actually not yet. We were actually being very playful and pushing the system probably until the computer crashed. And then this is the last version, the one with which we decided to then afterwards implement structure and try to propose it actually as a real building. A real building that actually doesn't have a facade, a real building that doesn't contain users. It's only an infrastructure. It's a vertical field. This is another project. It's actually a project that I did in Mexico with a group of students a year ago by now, where we worked also with information. In this case, we worked with colorimetric information. We worked with two colors that Luis Barragan, the Mexican architect, was working with. Both in San Cristobal and in his own house back in Mexico City, Luis Barragan was working with these two colors: a very bright pink color on the wall, and then a yellow mustard carpet at the bottom. So we realized when I was in Mexico, I was visiting these places with some Mexican architects, and for them this junction of color was incredibly subtle, all right. While for me, with maybe my European culture of color, it was something that was very unexpected and sometimes even a little bit disturbing because of the contrast of such strong colors. So that's the theme that I took to the workshop. We were with the students trying to question whether these two colors, they need to meet as a line, as here, one pink surface and one yellow surface, or whether we can use digital tools and let's say contemporary means of design to be able to avoid this line and to try to create a continuous transition from one color to the other. So we worked with incredibly simple means, and maybe it's important to say that I was hired in Mexico to come and teach digital fabrication and parametric design in a school which at that time didn't have means when it came to design and fabrication. So I went to the university without any means somehow to be able to teach. So I decided to do a workshop. I decided to do an analog workshop where we would work with simple materials, but where we would explore notions of parametric design. And for me, that meant to be systematic, to set up very clear design intentions from the beginning, but then afterwards really to try to work with numbers, simple numbers, but numbers, in order to realize an architectural space. So what we did is we printed paper with two different colors, with pink on one side and yellow on the other side, the two colors that Barragan worked with. And actually we invented a very simple system of folding. You can see that there is a gradation here on the sheet. The more you fold the sheet, as you can see here on the right, the more the yellow appears. The less you fold the sheet, as you can see on the left, the more the pink appears. No? So by working with numerical values, we would actually reveal one color or the other. And we were able, little by little, to create a gradient from one color to the other. So then in the classroom, we were exploring precisely this question of the gradient. How can two colors be mixed? How can we create a space that is neither pink nor yellow, but that is always both in different proportions? So we were testing, exploring a lot. And then eventually, this is the intervention being constructed. We worked with a simple timber structure. And then inside, we were hanging these 8,000 sheets of paper that were all being folded in a different manner in able to do to be able to achieve a gradient. We don't see it so well from here, but actually the inner part of the surface that is hidden is predominantly yellow, while the one on the other side, the one that we see, is predominantly pink. So the process of construction of this piece was interesting because we were running very late. So a few hours before the opening of the installation, we discovered that we had only hanged 1,000 sheets, and we needed still to hang another 7,000. So the act that we did at this moment, I was working with 15 students, is we decided to involve all of the other students that we could find on the campus. So the 15 students with whom I had been working for the last 3 days went around the campus, and they each found a group of 3 students that they brought into the building site. Or into the installation. I don't think we should call this a building site. So what happened there was very interesting, because every one of my 15 students had to communicate orders to the other 3 students, and because they had to communicate to them 4 values. They had to communicate whether they were on the bottom of the intervention or on the top of the intervention. So we labeled the bottom strings 1, while the top string 30. So there was a numerical value in the vertical axis, and then horizontally, whether we were close to the left edge of the surface or to the right edge of the surface, was an A to Z value. And then afterwards, they also had to communicate at the same time the amount of a folding that had to happen, whether the sheet was being little folded or strongly folded. So this was a numerical value from 1 to 24. 1 meaning that the sheet would remain almost only pink, 24 meaning that the sheet would then become yellow. So what was interesting in this moment is that the directing students, the 15 students, they were basically just communicating numbers. They were saying vertical 3, horizontal 6, folding 8, for example. And during an entire day of assembling this this paper installation, the only thing that were being heard in the space were numbers. We were talking about letters, we were talking about numbers, and this was the way to this was basically the only way to be able to construct this this very complex let's say surface of paper. So it's only at that moment that students were understanding that they were working here with an initial intention to work with colors, but then afterwards they were working very systematically with numerical values, with quantitative information, in order to make a construction happen. So this question of the gradient, this question of the continuous transition from one state to another, is something that I enjoy, and that I worked in the office with for a project in Switzerland, for a project for wine making. So it's a competition of which the brief is a space to promote Swiss wines, a kind of representation space. So immediately with the project, we decided to investigate wine. We started to look at very strong white wines, and we started to see what would happen if we would dilute them with water. Red wine is an incredible filter to light. It filters all the light except for the light of the red temperature. The light of the red temperature is the only light that is not corrosive for wine, actually. So a wine cellar, for example, a space underground where the wine is being kept, is a space where absolutely no light can enter, because light is corrosive for the material. But we understood that if we use wine as a filter for light, we will still get light into the building, but it's the precise light spectrum that is not dangerous, or that is not corrosive for wine itself. So we started to literally think about having a wine facade. Before that, we worked on a very simple structural system made out of wood, which you can see here, to actually really to try to create a very large indoor space with an important space, freestanding space on the bottom, to be able to house events, to be able to do a space that can take different types of activities or types of events. And then actually, since we had to, the idea is to be able to constantly have wines, bottles of wine, potentially expensive bottles of wine in that space, we needed to afterwards design a facade which would enable natural light, daylight, to always inhabit the space and to create somehow a homogeneous condition, but actually never to have any direct sunlight hitting the bottles of wine. So we then played with simple means of simulating with Grasshopper and with Ecotech, trying to understand how, by locating a facade, we actually changing the map of the solar incidence within the bottom space. So these are some images of the model that we did. You see that there is a gradient within the skin. The skin is we imagine the skin to be a glass module in which wine is embedded as a light filter, but the wine can be diluted from either being only red wine to being only water. And actually, this map that you saw before is what enabled us to understand where would we need to have a strong concentration of wine and where we could afford to have the facade to be translucent, in order to make sure that the wine inside the building, in the bottles that are being sold, is always protected. So these are a few images of the model. It's a project that we are actually still working on. Here you see the building from the inside, and then the facade that comes and close it, where we can clearly see this gradient. There is, of course, a relationship to the orientation. The west is to the left of the building. That is why we see the skin as being much more charged in wine and has to operate as a light field. Okay, I'm going to change now switch to another type of project. So these are pigeons that draw. You can see here 4 drawings that that were done by Lina and Pedro, 2 students at the YAC. And these are drawings that are being done by a metro, by the movement of the metro. These are drawings that are being done by the sea, by the waves, by a pendulum that is on a floating board in the sea in Barcelona. These are also drawings that are being drawn by the sea. The wave is creating a movement in a floating device in the sea, which activates the movement of a pen. These are drawings that are being done by Twitter. Whenever the word Barcelona is depicted within a tweet, it activates a motor that makes a pen, a board supported by 3 pens move or shake. These are drawings that are being done by a magnet, by 3 magnets, as a matter of fact. So it's a pendulum with a piece of metal and a pen, and below the surface of the page, it's 3 magnets that repel this pendulum, and therefore doesn't let the pen approach the area. This is an experiment that I did at IAC together with Rodrigo that assists me there. We called it the automated drawing or the drawing machine. We actually did an exhibition in Barcelona recently where we featured all of these drawings. I'm showing the drawing, but as you've seen in the videos, what I really ask the students is to make a drawing without using their own body. I ask the students to identify within their daily life a source of energy and to construct a mechanism, a machine that would enable them to draw. This was part of a design class in which we worked afterwards with public spaces, and what I was trying to avoid, the reason why we did this experiment, there are a few. One of them is that I'm convinced that, that as architects, one of the toughest subject to work with is time. And with these drawings, students were exploring time. They were being able, the more time would go by, to explore patterns, to explore organization, to explore behaviors that these sources of energy have. So the fact of being able to translate a source of energy into a physical representation, it's also something that I find incredibly interesting. The fact of understanding a context, the fact of doing a map of this context, all of these drawings, they are a map. They are a map of a specific moment, they are a map of a specific situation. And then there is another notion, which maybe is a very difficult one to be able to understand, is the notion of the accident, the notion of the undeterminate. All of these drawings, whenever the students would run this experiment, it would create a new drawing. It would create a drawing that would look maybe like the others, but that would be unique, that would be absolutely impossible to reproduce, literally. So the fact of having a drawing that shows a certain patterns of a phenomenon, yet that is completely unique, I think it's something that does reflect our world, somehow the complexity of our world, the complexity of our discipline also as architects, because as architects we need to construct, we propose to create environments, but what happens within these physical environments is something that is constantly changing and something that we cannot fully predict. No? So I think our job as architects, it's about being able to impose certain things to trigger certain reactions or certain events that we cannot fully anticipate. So our job, it's almost to construct matrices. So for that, I thought that this exercise was relevant and was interesting, and I'll use it then to switch to the topic of context. How can we use technology, machines, quite literally in this case, to understand the environment in which we are, or to understand certain characteristics of the environment in which we are. Here in this case, it's a project that is called 314, where what we've done is we've placed a camera that would take pictures of a public space in Barcelona, and take we've written a little script that would identify the position of every person at every minute of the time. And then in a museum, it's an installation. We have a CNC machine equipped with a pen and not with a mill that is drawing these photographs. So every minute is being drawn, and this is the type of drawing that it did. We actually worked a little bit with the code to be able not only to draw the person, but also afterwards to relate it back to a time. So on the right of the drawing, you see that there is a time scale. On the top, it's 10 o'clock. At the bottom, it's 4 in the afternoon. And what happens within the center of the drawing, it's actually a planar view of the public space that features the positioning of the people. And throughout the exhibition, which lasted 14 days, we created 14 drawings. Here we see only 10 because 4 actually failed. And these 10 drawings, they are the drawing of one day of the life of this square, no? And what I like is that, again, these drawings, they all really look like each other, so we can start to understand, depict certain patterns. However, we can also clearly see through these drawings that every day is a scenario in itself, and that there are specific things that maybe these drawings, they would enable us to go and read. And then, as I mentioned before, the failures, these are the 4 drawings where the script went wrong, or where a button got pressed wrongly, or when the photograph didn't get downloaded properly onto the computer. And I like to show them because somehow these are the ones that people most like. When people ask me for drawings, normally it's one of these 4. And I like the fact that even, you know, when technology goes wrong, this fact of this idea of the accident, of something that is unexpected, is something that often has not only a lot of beauty, but can also lead to other things, no? Such as many of the scientific discoveries that were done throughout history were done as mistakes. But I like to show this project because it relates to an academic studio that I used to run here in Paris at the École Spéciale d'Architecture, where I would ask students to look at some of the public spaces in Paris. Sorry, the very classical French planned landscaping spaces, which sometimes, because they are so framed and because they are so ordered, they seem to be homogeneous, or they seem to be undifferentiated them. And I would ask the students to go within these spaces and to try to map differences over time, to try to select a characteristic of these places and to record it, to map it, and then to create a drawing that would show something else than the space would show. So this is an example that I find interesting. It's actually a space that is, I think, 30 meters by 15 meters inside one of these parks. It's a surface of gravel. So when you look at the space, it seems like it's a totally generic, undifferentiated space. But what the students here did is they mapped the movement of people over time, and afterwards, having mapped the movement of people, they asked them their age. And these students, they documented themselves, and they understood that there is, or they learned that there is a relationship between the age of a person and the quantity of energy that a person emits. As a matter of fact, it creates a curve which has a peak at 24 years old. So that means that when we get born, we emit little amount of energy, but this amount of energy exponentially raises until 24 years old, and then it starts to degrow. So when the student was asking the name, the age of the people that were transiting through the space, they were able afterwards to represent graphically. This is a drawing that is actually done with Grasshopper, the intensity or the amount of energy that is being emitted. So this is a drawing of it's not a drawing of an instant, it's the drawing of a day. It contains, I think, 12 hours of time. It's a drawing that contains space also, but it's a drawing that shows us that within a public space, different amount of energy are being emitted different locations of that place. I would like to. I've explained that drawing to be able to explain one more project, which is a project of a group of students at the École Spéciale, where precisely they were looking at this kind of method of cartography to be able to plan an architectural intervention. This here, before they started the work, this is a picture of a table. It's a table in Paris, actually, in the architecture school. And what I like about this table is that it has been used so much that the surface of the table gets darkened by the amount of time it has been cut on. So these are all the strokes of the cutter. And what I find interesting in objects that are old, objects that I use, is that they very simply translate how they were being used. No? So if we do an analysis of this table, we are able, just by looking at an object, to understand or to speculate on how it was being used. And I think that this is something that we need to take care of within the design process. It's to carefully look at a place, to observe a place, to be able to understand how it functions in order to insert something and to make sure that this intervention is in accordance to the context or uses the context. So this project that I will show you now, it's the second one here in the photographs. I always ask students to find in the world or in Europe actually an abandoned building, a contemporary ruin, and to run mapping exercise on it to be able afterwards to convert these derelict architectural objects into something new, into something different. So in the case of these projects, the students went to Belgium, to a small industrial town where they have several cooling chimneys, and one of them is about to be taken down. So they were exploring this cooling chimney, and what I was asking them was really to do a cartographic experiment to be able to prove that the condition that they were finding there was a non-homogeneous condition, but a differentiated condition. In other words, that in different parts of the surface, such as the chimney here, different events or different characteristics occur. So this was in this case a difficult experiment or exercise, because the object that they found seems to be the same all around. Inside also. The moment the sun gets in, we understand that this object is not symmetrical anymore, that the light conditions are different depending on where you are within this concrete surface. And also the students, they were looking at the function of this place. It's a cooling tower, so it's a building that works with fluxes, it's a building that works with fluids, it's a building that works with cooling, and it's a building that works with ventilation. So what the students did, after rigorously analyzing the tectonic aspect of the building, understanding the structure, understanding the materiality, understanding the scale, understanding and even somehow imposing onto this building a kind of coordinate system to be able to do the mapping exercise, they run three analyses: one of light, one of humidity, and one of wind. And the one that they did of wind was with actually very simple homemade tools that they had in the school in Paris. They created a simple smoky environment, and they were able to look at where would the smoke travel, and therefore what were the areas of this chimney where there was most potential in terms of ventilation. So this is a drawing that I really enjoy. It's an unfolded map of the surface of the chimney. So it's not only a drawing that enables them to make models, because they just have to print this, to cut it, and then they can assemble a model of the chimney. But it's also a way to see the differentiation that happens within this surface. So when they overlapped, when they superimposed the light condition, the natural light condition on this chimney with the humidity condition, with the wind or the ventilation condition, they understood that it was creating a map which was very, very, very different. the darker areas are the areas where most light and most ventilation potential can be found. So I show again this image of the tower because it seems like this tower is the same at every of its points, but it really is not the case. And by understanding this map, by creating this map, the designers, the architects, or actually in this case the students, they were able to think of living units because they decided to convert this chimney into a village, and they were creating living units of which the dimensions were depending on the cross ventilation system and on the degree of porosity to light. So actually, just to put it simply, for example, wherever the map is darker, the depth of the dwelling would be longer, because it has more potential in terms of light and in terms of ventilation. So here you see again the original analysis drawing from the students, and then afterwards how this map is then being translated immediately through an algorithm into a living unit that has a certain dimension to fulfill simple comfort criteria. Here you see Guo, one of the students that is making his model, where you can see that every one of these dwellings is different. And then this is a short 3-month studio, so I think the students could have kept on developing this project, but they had to. They were caught with time, so when it came to really making this system operate in terms of programmatic requirements, they were a little bit short. So here you see some attempts to introduce vertical circulation within the system and really to transform this diagram into something that is livable and something that really can become a sort of village. Here's another shot of the model, and then this photograph, and I think I will conclude here. It's an image that I like because you have at the bottom of the page, you've got the drawing that these guys have been creating, and then you've got the model that is lying on top, where the model that they've created, the living unit, is all differentiated according to the map. So here you see not only the drawing, which is the tool, you see also the outcome that is derived from the cartographical exercise. So yeah, I had a couple of more projects to show, but I think I'm slightly riding over time. Am I not, Aldo? So I will leave it here. I wanted to show you these projects. Not a lot of it is constructed, but despite the fact that the theme, the thematic on which you're working is very much the urban space, I think that the relationship between information that we find, that we gather, that we collect, and what we can do out of them in terms of physical or organizational outcome is something that is something that we constantly need to work with as architects. So for me, showing these examples, it was a way to show one way of dealing with this problematic, and I hope it helps you in your design process. Yes.
Okay, that's a lot of 1 hour. If you want, you can close the lecture.
Yes, I just did.
Perfect.
I just did. I don't know if there's a delay. There's no delay.
No. I know this lecture. I know that there are other beautiful things that you would like to present. I know it. It's just that it's in the middle. It's in the middle of our working day, and we need to keep it in 1 hour slot. That's the only reason.
Absolutely. So yes, I've just concluded. All yours.
Letis? Okay. So I cut it.
No. I was concluding. So you interacted exactly at the right moment.
Okay, perfect. So I guess it's I was looking again at the presentation, and today we had let's say midterm review of our projects. And actually, we were discussing and trying to understand with the students how to implement the data visualization and the data collection that they did so far into the project. And your approach actually is super interesting because the data collection itself is producing, a proposal somehow. It's producing through these drawings. They are always related to time, to some specific conditions. You are already proposing kind of, let's say, a representation of the space. So I see a potential in what we are trying to do here with with the smart cities and with drones and your machines. Of a combination, a possible combination where we can start to probably in the next events, in the next series and evolution, try to implement probably those two world, the machine that you are building and the sensor and robots that we are using for the data collection. I guess it's already, it's giving already a different vision of the space and it's telling already a story. It's an interesting story. So it's a very, very interesting approach, yours. And personally, I will try, yes, to stress it out, to implement this approach even in my own, in my own research sooner or later. And I'm very happy of the chance that you gave us to see your work. I'm happy also that Tehran was here, that New York is connected with us, and of course that our students in Beirut are there watching and looking at us. So I'm going to close now your lecture, and thank to you and to Rasha and all the organizer, and Carla and all the organizer of this beautiful event. I remind to everyone that tomorrow we will have the lecture from Nader Terani from New York at 15:30. So we will not do it on Friday, but it will happen on Thursday. And that said, Eduard, thank you, and you can close from Paris your lecture of Beirut.
Great. Thank you so much for the invitation, Aldo, and thank you all of you for listening.
Thank you.
Thank you.